GM, been getting a lot of questions about the SEDA tokens utility in the SEDA network, so I thought the best way to show you guys was using my peas and my pumpkin seeds. First, let's just go through the setup. This block here, this is any other blockchain network. The pumpkins, USDC, any stablecoin, any other currency but SEDA. Our bot in the middle, my little transformer here, represents our solver network, centralized exchange, the SEDA network, overlay nodes, data provider. This here is the burn address for SEDA tokens, which will come into play shortly. So the TLDR on SEDA is that to pay for a data request, you can use any other currency to pay for that, so you don't have to hold SEDA on other chains. The reason is that that's great for our economic security, keeping SEDA on the SEDA chain. But if you pay using a stablecoin, then how is SEDA involved in the data request? Well, it turns out that SEDA is the only Oracle with an on-chain economy. I'm going to show you how that works today. Let's say that our blockchain wants to post a data request to SEDA. Well, the way that it integrates is to approve a contract, which is monitored by our solver here. So let's say it pays for its data request. It puts its USDC equivalent of the data request value into the solver's wallet. The solver sees that and agrees to the terms and conditions of the data request. And in receiving that USDC, it then has to use SEDA tokens on the other side to execute that data request. So it takes some SEDA tokens, the exact same value minus its fee from the USDC, and it executes the data request. Now, what happens? With our SEDA tokens here, a portion goes into a burn address, boom, never to see light of day again. A portion goes to our overlay nodes, and a portion goes to our data requesters. And what happens is that the solver then relays the data request to the SEDA chain. The overlay nodes call the Oracle program ID of the data requester, and they go off to the data sources, in this case, this one. They query the data source individually, 1, 2, 3, 4. They go back, they post their reveals to a DR tally, and then it filters and aggregates all the data into one readable data point that goes back onto the SEDA chain, put into the next block as a batch. The solver then picks up that batch and relays that batch back to our blockchain that initiated the data request. And all of that process has to happen by accepting the USDC on one side, using SEDA tokens to reward the overlay nodes that are participating in that data request, and the data provider that is providing the data for that data request. And a small portion comes into the burn address. But let's take a look at what happens over time. More USDC goes in, more SEDA tokens go out. More data requests come in, more SEDA tokens go out. Overlay nodes and data providers. And because they can go to any chain, data requests are coming from left, right, and center. But what happens? The solver now has a wallet full of stablecoins, USDC or any other currency. Now it's out of SEDA. How can it continue participating in executing data requests or relaying the data request between SEDA and the blockchain if it's run out of SEDA? This is where centralized exchanges or other sources where you can access more SEDA tokens come in. The solver goes off to the source of SEDA tokens external from the SEDA network, puts its USDC in to the centralized exchange, for example, and swaps it for more SEDA tokens. The solver comes back, our network has collected more stablecoins, and the cycle repeats. Stablecoins go in, solver relays the data request, burning a portion of SEDA tokens, a few of the overlay nodes involved, and the data provider, and the data request is executed from the SEDA chain to the overlay nodes that query the source, give their reveal back, data goes back to the chain, solver gets it, boom, solver unlocks its USDC for completing the transaction. So this is how we can say that we have the only on-chain economy. Most oracles have staking, some kind of mining setup and governance. But for SEDA data requests to be executed, the solver needs to have a balance of SEDA tokens. And why that's great is because when its stablecoin balance gets full and its SEDA token balance gets emptied, in order to participate ongoing, they must go back to a source of SEDA, swap their stablecoins for more SEDA, come back to the game, and start relaying more data requests. And the good thing about the burning of the SEDA tokens here is that a lot of people, when they burn from their minted supply. And because we're a Cosmos SDK, we do have the mint module that goes to reward the validators of the main chain. But SEDA being burnt for data requests is coming out of the circulating supply. That's a massive difference between people that burn tokens from their minting supply. It's like creating Ps over here, putting them straight into this address. It doesn't work that way with SEDA. The Ps that go into the burn address, and in this case the SEDA tokens, come out of our circulating supply, creating a natural on-chain economy for the SEDA tokens.